The structure of the objects used in application development is mapped to tables in the database system. The attributes of these objects correspond to the fields of the table. A table consists of columns for fields and rows for entries. The table has a name and different general attributes such as delivery class and maintenance authorization. A field has a unique name and attributes, for example, a key field. A table has one or more key fields. The values of these key fields uniquely identify a table entry. These key fields collectively are called as a primary key. You must specify a reference table for fields containing a currency having data type CURR or quantity having data type QUAN. A reference table must contain a field, that is, a reference field, with the format for currency keys having data type CUKY or the format for units having data type UNIT. The field is only assigned to the reference field at program runtime.
The basic objects for defining data in the ABAP dictionary are as follows. Tables. Table is used to define transparent tables on the database system. You can store business data in database tables. Domains. A domain is used for the technical definition of a table field, for example, field type and length. It also describes the value range of a field by its data type and length. The value range can be limited by specifying fixed values. Data element. A data element is used for the semantic definition, for example, a short description of a table. A data element also describes the meaning of a domain in a certain business context. The data element primarily contains the field help or F1 documentation and the field labels on the screen. A field is not an independent object. It is table dependent. You can only maintain a field within a table. You can enter the data type and number of places directly for a field. No data element is required in this case. Instead, you can choose a predefined type to specify the data type and number of places. Specify a built-in type to define the data type attribute of a data element and enter the data type and number of places directly.
The table SPFLI stores the flight schedule. A table is automatically created in the database when a transparent table is activated in the ABAP dictionary. At this time, the database independent description of the table in the ABAP dictionary is translated into the language of the database system used. The database table has the same name as the table in the ABAP dictionary. The fields also have the same name in both the database and the ABAP dictionary. The system converts the data types in the ABAP dictionary to the corresponding data types of the database system. The order of the fields in the ABAP dictionary can differ from the order of the fields in the database. Therefore, you can insert new fields without having to convert the table. When you add a new field, the system adjusts the list of fields by changing the database catalog. This mechanism is called alter table. ABAP programs can use a transparent table in the following ways. You can access the data contained in the table with OpenSQL or native SQL. You can use the transparent table as a structure type when defining variables or more complex data types. You can also create a structured type in the ABAP dictionary for which there is no corresponding object in the database. Such types are called structures. Structures can also define the types of variables.
The include mechanism exists to avoid redundant structure definitions. You can reuse structures by including them in other structures or tables. A table cannot be included in another table. Includes may contain other includes. Foreign keys defined in the include structure are passed on to the including table. The technical settings optimize the storage requirements and the access behavior of database tables. When you activate the table in the ABAP dictionary, the system automatically creates the table in the database system. The technical settings define how the table is handled when it is created in the database system. The settings for the data class and size category determine the storage area to be selected, that is, table space, and the expected table size. The settings for buffering define whether and how the table should be buffered. You can define whether changes to the table entries should be logged.
Particularly tables that include transaction data can have large gaps in their allocated memory space due to the fast growth or frequent changing of the data sets, as well as the insertion and deletion of data records. This fragmenting of the data on the hard drive of the database server always leads to repeated performance problems. Simple measures such as creating an index cannot rectify these problems. You must distinguish between fragmented indexes and fragmented tables.
If the index belongs to a large table of greater than 100,000 data records, the index recreation process may take several minutes or even hours. While recreating the index cannot be used for database access, which may lead to increased response time when reading table data due to full table scan.
You cannot read or change the content of the table during the conversion process. Depending on the table size, the conversion process can last for several minutes or hours. In a productive environment, therefore, you should exercise care when executing the conversion. The conversion should take place at times when the load on the system is at a minimum, for example, at night. The database system has different physical storage areas known as table spaces. The data class defines which table space is used for a specific table within the database system. The most important data classes are as follows. Master data. Master data is the data that is seldom modified. An example of master data is the data of an address file, name, address, and telephone number. Transaction data. Transaction data is the data that is frequently modified. An example is the material stock of a warehouse, which can change after each purchase order. Organizational data. Organizational data is the data you can define when you customize and install the system and is seldom modified afterwards. The country keys are an example. System data. System data is the data that the SAP system needs. The program sources are an example. The size category describes the expected storage requirements for the table in the database. When the system creates a table in the database, it reserves an initial extent. The size of the initial extent is identical for all size categories. If the table needs more space for data at a later time, further extents are added. The size category specified in the ABAP dictionary determines that these additional extents have a fixed size. You can choose a size category from 0 to 4. Depending on the database system, each size category has a fixed extent size. Correctly assigning a size category ensures that you do not create a large number of small extents that may increase table fragmentation. At the same time, do not choose a size category that is too large and wastes storage space.
You can use logging to record and store modifications to the entries of a table. To activate logging, select the Log Data Changes checkbox in the technical settings. Selecting the flag in the ABAP dictionary is not sufficient to trigger logging. Logging is only performed if it is enabled in the System Profile parameter REC/client.
In addition to transparent tables, where the definitions in the ABAP dictionary and in the database are identical, there are pooled and cluster tables in the SAP system. Pooled and cluster tables are characterized by the fact that several tables logically defined in the ABAP dictionary are combined in a physical database table as table pool or cluster.
In cluster tables, you store functionally dependent data which is divided among different tables in one database table. Accordingly, the intersection of the key fields of the cluster tables form the key of the table cluster known as the cluster key. A table pool, as opposed to a table cluster, stores data records from the tables defined in the ABAP dictionary that are not dependent on one another. You would like to combine small SAP tables in one database table.
The primary advantage of pooled and cluster tables is that the data can be stored in compressed form in the database. This reduces the memory required as well as the network load. Combining tables into pooled tables or cluster tables results in fewer tables and fewer table fields due to data compression. The result is that fewer different SQL statements need to be carried out. Because pooled and cluster tables are not stored as separate tables in the database, administration is simpler. With cluster tables, functionally dependent data is read together, which results in fewer database accesses. The main disadvantage is that database functionality is restricted. It is not possible for non-key fields to create an index. There are neither primary indices nor indices on a subset of the key fields. The use of database views or ABAP joins is also ruled out, as our table appends. You can access the data in pooled or cluster tables only by OpenSQL, not native SQL. The SAP database interface splits the where clause of an SQL statement. Only the where condition for key fields is transferred to the database system. Order by or group by clauses are not transferred for non-key fields. You need longer keys than semantically necessary for pooled tables.